Okay, you guys, we're doing 12-6 today. We're doing probability and the addition rule. So you'll see how much it's a little different. So yesterday, we learned in 12.5, we learned multiplication rule, and it involved the intersection. That was your key word, intersection of two or more events. And here's what I need you guys to make sure you're aware of when you see the word end. So what do I want to stress to you guys? R-E-A-D. Reading is important. You guys know if it's an end, then you take the probability of A times, just to review, the probability of B. So that's what we learned yesterday, the intersection of the events. So today we're going to be doing the union of two or more, and here's the biggest difference. Hopefully you guys see, obviously, an or. Okay, so yesterday we did intersection with the and, today union with the or. So it says to find the probability that one event or, I can't stress it enough, occurs, we must know how they're related, kind of like how we did with those. So you have something called mutually exclusive. So for two events to be mutually exclusive is if they have no outcomes in common. It can happen at the same time, and I gave you guys a couple of examples, so let's take a look. A junior or a senior winning an election. Well, they're mutually exclusive. You can't have somebody that's a junior who's also a senior, okay? Take a look. I wrote ME for mutually exclusive. A sophomore or a female winning an election. Well, think about this. A sophomore can be a female can be a sophomore. So for this, we're gonna say not mutually exclusive. Okay, for the next one, drawing an ace or a club. So, well, if you think about it, you have an ace that's a club in the deck of cards. So again, not mutually exclusive. They to be mutually exclusive, they can't have anything in common. So if you thought of a Venn diagram, you know, and your diagram again looks like this. Let's just put a 1, 2. Nothing is in common. Okay, and here's your formula to find it. So it says two events that are ME, mutually exclusive, which again means nothing in common, then the probability of A, or again that keyword is or B. What you're going to do is you're going to find the probability of event A, and all you're going to do is go plus the probability of event B, right? They're completely different. They're separate events. Well, here. Well, that. Who knows how that just fell? There we go. Okay. So the probability when you guys are doing or, you got to read it. Or is an addition sign, and end is a multiplication. So make sure you guys are aware of that when we put everything together. Get that visual. End, multiplication, or is a plus. Okay, so for example, it says in a standard deck of cards, what is the probability of getting a 10 or a face card? First of all, you see that, you know, they have nothing in common. You have 10s and face cards, they're not together. So what's the probability of getting a 10? Told you need to know a deck of cards. 4 10s out of 52. Read that key word, or means plus. Face cards. Well, you have 4 face cards. I'm sorry, you have 3. Remember, face card is a jack, queen, king, and you have 4 different suits, right? Hearts, diamonds, clubs, and spades. So that means there's 12 face cards. Out of 52, we add it, and I want all of your fractions in simplest form. So you guys can give me 4 out of 13, which let me just take a quick look what the textbook does. So the textbook either leaves it as the fraction, or you can make it a percent, which would be 30.7, so about 31%. I don't care which one you guys do. Okay? All right, next question. So 2 dice are rolled. What's the probability that doubles or the sum is 9? Again, there's nothing in common. You can't roll. There's no 2 sums that are going to equal 9. So these are what we call, again, mutually exclusive. So how do I find it? Well, how many doubles can you roll? 1, 1, 2, 2, 3, 3. You get it. 4, 4, 5, 5, and 6, 6. Those are doubles, right? So we have 6 of them. Now think about it. If you have 2 dice and you roll them, how many possible outcomes are there? Well, let's see. You can do 6 times 6, right? You have to make sure you understand. If you think back to the counting principle, I'm just going to write CP for counting principle for the total outcomes. You have 6 for the first, right? 1, 2, 3, 4, 6 times 6 for the second. So there's a total of 36 when you roll 2 dice. Plus, I'm going to mess that up. What's the probability the sum is 9? All right, let's see. Well, 1 cannot match up with anything because it's 1 and 8. That can't work. 2 can't match up with anything because the highest number is 6, right? Okay, what about, so we want to figure this one out. 3 and 5, oops, that was dumb. 3 and 6. So on my first die, I can roll a 3 and a 6. Now, think about this for a moment. This is my sample space. You could also do a 6 and a 3. Okay, so you could also do the 6 and the 3 because I can, again, first die and second die. The reason why 2, 2, 2, 2, they're the same thing. It doesn't matter. Okay, so that's 9. Let's try 4. Well, 4 and 5 is 9, and so is 5 and 4. Okay, did that. And that'd be it, correct? So 1 can't do with anything. 2 can't do anything. 3 would go with 6. 4 would go with 5, and 6 back to 3. So those are your possibilities. I would say listing them when you guys are doing this. So we have 4 out of 36. Okay, let's add it together. So what do you got? 6 out of 36 plus 4 out of 36. You should get 5 out of 18. I told you I want all of your fractions simplified. Or you can say about 28%. Okay? So that's mutually exclusive. Now, for something to not be mutually exclusive. So not mutually exclusive. It says 2 events are not mutually exclusive if you could think there's some kind of overlapping. So if they have something, and I will show you, in common. Oh, I kind of ruined that. So if they have something, sounds like a horse running in my house. It sounds like you have something, if you have something in common. For example, here's a perfect example. Rolling a number greater than 2 in a die. So greater than 2 is 3, 4, 5, 6, or even. Well, here, 4 and 6. So you are overlapping. So I wanted to use the word overlapping because think of a Venn diagram. When you guys have rolling a number greater than 2 would be a 3, a 4, a 5, and a 6. And the even numbers are 4 and 6. They're overlapping. So they both have it if you were to roll the or. So there is something in common. So we have to take into account for that. So, to find 2 events if they're not mutually exclusive, which means something's in common. So when you're doing these problems, you have to first decide, just like you did yesterday with independent and dependent. Like replacing, I know a lot of you guys know that one. To replace or not replace, you have to take that into account. So you have to take something like this into account. It's really important. Are they mutually exclusive or are they not? Do they share something? And here's how you guys find when they share something. To find the probability of A, again, here's the or. You're going to first take the probability of A. Then you're going to add the probability of B. But here's the key thing. You're going to subtract the probability of A and B. And what this is, you could think, is what they're sharing. The sharing amount. So minus the probability that both occur. If that makes sense, okay? So that's why it's very different. Again, when you guys are doing an or, it's plus. This is mutually exclusive. This is not. And the end is multiplication. Okay, so let's see how this comes into play. So it says you have a standard deck of cards again. What's the probability of black card or jack? So even if maybe you're thinking, like, I don't know if it's mutually exclusive, just go right into it. First, tell me how many black cards there are. There are 26 black cards. You see the or, plus. How many jacks are there? There are 4, I just drew a blank. 4 jacks. Now stop there. Think to yourself, Are there anything in common? Well, if you think about this, you have 4 jacks, right? Jack, 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 jack. 2 of them are your red, 2 of them are black. So what you have to do is, if you think about this, with included in these blacks, you included 2 jacks. With included in your 4 jacks, you included 2 black cards. So that's what it means for the overlapping. You're double counting them. So if I'm double counting them, then I need to get rid of what I double counted, and which is why you subtract the 2. Okay, simplify it, put it in your calculator. You're gonna get 7/13. Or you guys can give it to me as a percent, which is about 54%. Okay, so let's take a look at the next one. What's the probability of drawing a face? First of all, I see the word or, so I know it's an N, maybe a plus, sorry. So face cards, how many face cards are there? Well, you have a jack, queen, king. You have 3, but there are 4 of each ones. So you have 12 face cards. How many spades? You have 13 spades. Then stop there and say, do you have any face cards that are spades, or do you have any spades that are face cards? However you want to think about it. And if you think about, you have jack, again, queen, king, and you have it 4 times. Well, how many of them are spades? Well, 3, right? Because you have jack, queen, king for the spade, jack, queen, king for the diamond, and so forth. So you have to minus the 3, the overcounting. They're a little hard. You do need to think about this. Put this in your calculator. You get 11/26, which as a decimal is about 42%. Okay, a lot of times with cards, I leave it as the fraction, but I just want to give you guys both. All right, next one. We're almost done, you guys. Short lesson. A die is rolled. Okay, what's the probability that, I don't even know what I was writing, you roll, let's say, a number greater than 4 or even? Or is your key word, because I could trick you and put the end. So how many are greater than 4? Well, you have 5, 6. So 2 numbers are greater than 4, and the total is 6 because I'm only rolling 1 die. Plus, how many are even? 2, 4, 6, 3. Minus, how many of the numbers greater than 4 are even? Well, greater than 4 is 5, 6, so only 1 is even. All right, let's put this in our calculator. 2 plus 3 is 5. 5 minus 1. So 4 was 6, so 2/3, or about 67%. Pretty simple, I hope you guys think. Okay. One more problem. Okay, so these are not in your textbook, but I like to do these. I've did these before, so I want to make sure you guys watch these. Maybe you guys can use common sense for them. Well, I'm going to actually do the formula because some of you guys like algebra. Sorry, just trying to get comfortable on the floor. So here's what you're going to do when you're reading these. Again, they're not in your textbook, but you're going to see them, so make sure you guys are watching. So it says, out of 200 students, 113 are either varsity or on the honor roll. Okay. 74 are varsity, and 51 are on the honor roll. What is the probability that a randomly selected senior is on varsity and the honor roll? So we got like an and, we got an or in this thing, get a bunch of things. I don't care how you guys do it. I will say some of you guys are bright enough to use your common sense in doing this. As I told you, probability is, but I would say I'm a little bit slower on that. So I use the formula, meaning what? The formula when you have, your or is here. You have the probability of A or B, we know, equals the probability of A minus the probability of B, plus, that was my fault, minus, there we go, the probability of A and B, right? We just talked about that formula. That's for not mutually exclusive. Okay, so once you have that, watch how easy this is. What's the or? So you have 113 out of 200 kids are on the or, okay? We'll say A is the varsity athletes, so we have 74 over 200, plus B will say, B is your honor roll, so we got 51 out of 200, minus what's the probability for the end? I don't know. Let's put it over there. And then you're just doing the algebra. I just think it's easier to do that way. Maybe that's just the way my brain works. When I read, sometimes I forget what I'm reading and I drift off. So again, you guys can use some common sense there. When you guys do it, you guys just add and then minus. And in the end, you're going to get, what's the probability? About 6%. Now, don't move on. I'm going to ask you about, I can say this, how many students are varsity and honor roll. So that's going to be my next question for you. Well, that's pretty simple. If 6% of 200, in your calculator, put 6% of 200, and you have approximately 12 students. Done. Okay, so let's go on to the next question. We're going to do the same thing. So you're using the same example. It says in above, suppose you have 32 are in band now, and 64 are in both. What's the probability that they're, 64% are in band or the honor roll. What's the probability they're both? So using your same formula. Well, you have a total of how many this time? Or for the or. Seniors band, 64 seniors are band or. So here's your or, and that's 64. So it would be 64 over your 200 equals, let's say band is A. So we have 32 over your 200 because you're using the 200 from above. Plus B will be, what's B? B is your band honor roll. How many were in the honor roll? Come back up here. So we have 51 were in the honor roll. So now minus the end. So put that in your calculator. You guys solve it. And you're going to get approximately 9.5%-ish. So 9.5%. 200 would give you guys about 19. So I'm going to ask you the same question. How many students? So 19 students. Okay, one more time and you're done. Okay, so it says, in a survey of 300 students, okay, 150 like pop or country, 97 just like pop, 83 like country. What's the probability that a randomly selected student likes both? And about how many students? So 2 parts again. All right, so here's what you guys can do. First, it's the or equals, we'll say event A plus event B minus A and B. So obviously it's P for probability. Put that up there for yourself. So again, it's not on your homework, but I am asking on your reviews. So what's the or? So we have 150 are the or, and there's a total of 300 equals, let's make pop my A. Let's make country my B. Minus question mark, you don't know, and it's out of 300. So add, minus, do what you got to do, and you get a probability of approximately 10%. So how many students? So about 30 students. And you're done. So you learned again. Remember, or plus and multiply. But you have to, for each of them, figure out, are they for or, mutually exclusive or not? And then obviously if they're not, you have to do the subtracting, and the ends you are multiplying. All right, you guys.